Hello everyone. Welcome to the session 1 of the 2024 APRU SWM Global ESG and Sustainability Lecture Series hosted by the APRU Sustainable Waste Management Program. Today's lecture will be delivered by Professor Michael Goodsite of the University of Adelaide, Australia. Following the lecture, we'll have a panel discussion and a Q&A session. I'm Samhita Ankareddy, the moderator for today's session, and I'm also a PhD student at Korea University. Before we begin the lecture, I'd like to ask Ms. Christina Schoenleber, the Chief Strategy Officer at the Association of Pacific Rim Universities, APRU, to speak a few words about the program and open the session.
Hello there. Hello, good morning and good day, everyone. Very nice to be here and thank you for the kind introduction. Let me share my screen, my slides. Okay. Can you see the slides?
Yes, you can see.
Thank you very much. So I'm Christina Schoenleber. I'm from the Association of Pacific Rim Universities, and I just briefly want to introduce what we do and who we are and what we do for the colleagues who have not heard of us. And very nice to be here, and thank you very much for the invitation. So the Association of Pacific Rim Universities, or in short APRU, we are not a university, but we are a network of leading universities that span the continents across the Asia Pacific, the Americas, Asia, Australasia. We bring together the leading universities that are based around the Pacific and researchers, policymakers, and external organizations. And our aim is to collaborate on solutions to the challenges. And we specifically talk about the challenges of the Asia Pacific, which often are also the challenges of the 21st century. So we were set up over 25 years ago as a university network, and we at that point already were looking to really support the development of the Asia Pacific region through scientists, through the research that takes place within our member institutions. And we still do this, but now the challenges are slightly different than 25 years ago. Really, we focus on key problems of the region. And we believe that we have through the unique network, we have a connectivity that allows us to span geopolitical and geophysical differences. And we really have through our members that we have the expertise in global issues. And really, we're looking to collaborate for impact. As a collective, we're stronger than the individual university. So it is about positive change that we're looking for. So we started out with a network of about 20 universities when we set up, and now we have 62 leading research universities acting together for impact. And you can see on the slide that the 62 cover 19 economies across the region. And but we also collaborate with other universities beyond the network, beyond this network, when it comes to really solutions to some of the challenges. But I'm sure many of you can find your own university there, or the universities within the economy that you're based. So how do we do what we are trying to do, and what are our priorities? We really aim to leverage the collective education and research capabilities in the international public policy process. So we don't do, in APRU, we don't really look to do our own research. Our members institutions do this. We don't do technology transfer, but the majority of things that we do is we bring together the expertise, and we really look to influence public policy and support policymakers through the insights that come out of our programs. And I guess in the post-pandemic era, what we've developed now are 3 key strategic priority areas to focus on. And it is really about providing a neutral platform for higher level policy dialogue, exploring innovative solutions for sustainable futures, and supporting diversity, inclusion, and minorities. these are some of our key strategic priority areas. So how does this work? We are clearly a network of many institutions. So we are guided through the presidents from our institutions. And we have a steering committee where we have the president sitting on of them. And you can see our current steering committee of elected presidents. And it oversees all that we do, our programs and finances of the networks. And colleagues are voted on the network for 2 years, and they can also then extend for another 2 years. And this is our current committee. And in terms of the work that we do, we aim to provide value to our members, and we provide value to the region through the work that we do. And you can see here what we call our Pentagon, and it gives you an oversight of 5 key areas. So if you start with the top left-hand side, our One Pacific focus areas, and I just want to say these are some examples that we have sitting under these specific areas. This is not everything we do. We do actually quite a lot more, and some of these areas are very established, and some of them are new. But under One Pacific, these are the program areas where we want to address the challenges of the region. And under sustainability, you have the global sustainable waste management program sitting in addition to some other sustainability focused areas. And then we also work together with our members to really think about what the University of the Future looks like. And that is really then to add value to our members through some of the activities that sit under this. So we have a big generative AI project, for example, running as part of this, but we also think about future models of education and what institutions can do together within a network like this. Another area is the Pacific Classroom, which really focuses on student activities. Many of these are also driven through some of the programs that sit under One Pacific, including the Sustainable Waste Management Program, which is one of our highly valued program areas. But then we also really look at what we can do in terms of cultures and diversity as one of our strategic priority areas. And we have activities there, such as like our Asia Pacific Women in Leadership Program. We think about what we can do with underused resources and facilities within our member institutions, where the museums sit under, for example, and also very much focus on the indigenous knowledges area that span our members across the region. And then under APRU Connect, we have a lot of our governance activities, such as our APM, annual president meeting, or other governance meetings, and where we bring senior academic staff together, and administrators, and other activities, again, that focuses on the actual network activities. Just to give you a brief overview of the holistic activities, but then going on and thinking what sits under the One Pacific challenges. These are some of the areas that we focus on, which are global health, multi-hazard Pacific oceans, digital economy, sustainable cities and landscape, and our very important sustainable waste management program. And these programs are hosted by our member institutions and led by highly experienced researchers and senior academics. As you can see the pictures here. And we have also Professor Yongsik Oke, who you will listen to in a minute about the Sustainable Waste Management Program. But I have to also mention the challenges that the programs address are very multifaceted and also overlapping. So we have also many activities within the programs where they engage with each other. And if you listen to the whole lecture series this year, then you will also meet some of the other colleagues from the other programs, APU programs, who will give the lectures. And then we also, alongside these challenges, we have activities, as I mentioned, under that foster the network, but also focus very much on students' activities. If you think about, we have at the moment 20 economies and over 2 million students and 200 faculties that we look after. And so we have many activities focusing on students, such as this series, for example, or early career researchers. But we have other programs such as the undergraduate leadership program, or for example, another program is the Asia Pacific Open Dialogues or virtual student exchange programs, which are all activities, or the Indigenous Knowledge Working Group that you can find out also from our website. And then I have to say, we cannot do all of this on our own, even though we're not on our own, but not even just with our institutions, but we have a lot of external partners that we work with, and they help us translate some of the insights that come out of the programs into policy. So we are guest members of the Asia Pacific Economic Cooperation, the APEC, for example, and we work with the ADB, with Elsevier, with Google, and also, for example, the Sustainable Waste Management Program brings a lot of external partners in and together to work with academics and the programs to help us achieve impact and change within the region that we're looking for. So I just want to mention really briefly some future projects. We always work on new ideas. I mentioned already the University of the Futures Working Group. That is a new initiative that was set up earlier last year, for example, but we started the first program there, or the first project, which is the Generative AI project, where we get our institutions together to think about what does the future of the university look like based on new technologies. So that's one of the new programs. And then another program is where we now think also beyond the activities that we have under some of the for example, our APRU biodiversity program, but where we think of where can our network of institutions that, for example, have labs and research labs connect, and specifically on forest labs, for example, here. So we want to make it more impactful for institutions, for researchers, for practitioners to work together, but also to address some of those challenges. And we know that we have through the SDGs some really full back on some of the biodiversity work, and we hope that through this new initiative we can also push this forward further. So it's just one new initiative that we're thinking about at the moment with our institutions. And with this concludes my brief introduction of APRU, and I would like to hand over now to Professor Ock, who will give you more insight of the program. Thank you very much, and I will stop sharing my screen. There you go. Thank you.
Okay, thank you, Christina. Can you hear me well, Samita?
Yes, Professor.
Okay, so good morning. Hello, everyone. I'm Yongshik Ok, Director of APRU Sustainable Waste Management Program. Our program is an integral part of the APRU membership and consistently work toward achieving UN Sustainable Development Goal through thoughtfully designed event and program aimed at raising awareness of sustainability, UN SDG and ESG. To date, we have had privilege of hosting quite a number of major events, conference and forum around ESG management and sustainability, including but not limited to Australia, Singapore, Indonesia, and South Korea. We co-organize an online course entitled APRU Global Sustainability, Waste and the City, which educates students on UN SDG, methodology to achieve them, collaborative approach with stakeholders in implementing sustainable practice, and expose them to ESG reporting and its interpretation. So I'd like to highlight our flagship APRU Sustainable Waste Management Global ESG Lecture Series, which is initiated in 2021 in partnership with the International ESG Association and the Korea University ESG Research Institute. We launched this lecture series to provide a world-class learning platform open to academic, student, and industry professional, enabling interaction with renowned experts. So we have invited leading experts in sustainability for this lecture series, and you can find more information on our website regarding speakers and registration. Additionally, we have two upcoming conferences: the 7th Global Conference on ESG Management and Sustainability, scheduled for August in Indonesia, and the 4th Australian Circular Economy Conference, set for October in Australia. So moving to today's session, Professor and Pro Vice-Chancellor Goodsite will discuss Australia's leadership in hydrogen, metals, and minerals, and the environmental challenges it faces, and future opportunity. So following the lecture, Professor Goodsite will engage in a discussion with a panel of expert group drawing on their expertise and geographic perspectives. So thank you. And now over to Samita.
Thank you, Ms. Schoenleber and Professor Oak, for opening the 2024 SWM Global ESG and Sustainability Lecture Series. Before we dive into the session, I'd like to give you all a brief about our speaker today. Professor Michael Goodsite serves as the Foundation Pro Vice-Chancellor, Energy Futures, and also holds the complementary role of Director of the Institute for Sustainability, Energy and Resources, ISER. His primary responsibility is to solidify the university's standing in renewable energy technologies and sustainability, positioning it for a leadership role as the state and nation transition to a new energy future. He oversees the university's executive functions in commercialization, business development, and research partnerships, and serves as the Managing Director of Innovation and Commercial Partners Proprietary Limited. Professor Goodsite coordinates relevant research activities across the university's faculties, as well as with strategic external research partners, and represents the university in matters related to sustainability and energy futures at various governmental and industry levels. Furthermore, he leads the implementation and development of the university's FAME sustainability strategy, FOSA and Magnets for Excellence, providing oversight of the university's sustainability initiatives on behalf of the Vice-Chancellor and Deputy Vice-Chancellor. Professor Goodsite holds a Bachelor's of Science degree in Civil Engineering, an MSc in Environmental Engineering, a PhD in Climate and Environment, and an MBA in Global Management. He is a Fellow of Engineers Australia and the International Union of Pure and Applied Chemistry. In addition to his academic work, he is actively involved in supporting diversity initiatives, including initiating a mentorship program for women. You can also gain insights into his latest research and publications by searching for Professor Goodsite on Google Scholar. At the end of the seminar, we'll have a panel discussion and a Q&A session, and I request all of you to actively interact with Professor Goodsite and our panelists. With this, I would like to extend a warm welcome to our speaker, Professor Goodsite, our panelists, and our participants. Without further ado, Professor Goodsite, the floor is all yours. Thank you. Professor, you are on mute.
There we go. I'm hoping you can see my screen in the PowerPoint presentation.
Yes, it looks
excellent.
well.
Thank you so much for having me. It's such a pleasure to be here online with you all. I think that COVID has shown us that we can get together and learn from one another online very readily, which for all of us who appreciate sustainability, really appreciate that technology can bring us together, and also challenge just how we impart knowledge as academic experts. I'm Michael Goodsite. It's very nice to meet you all. Today I'm going to talk about South Australia and as a case, our leadership in hydrogen, metals, and minerals, and the environmental challenges and opportunities that come with that. I'm so honored to be here with such a distinguished program, APRU, SWM, and everything that we learned about it just prior to my speaking. Congratulations to everything you've achieved, and to Professor Oak for his leadership and the leadership of the team around you for all you've accomplished, and thanks for the team in advance for bringing us all together. So Firstly, I'd like to point out where I am. This Adelaide is in South Australia, and I don't know, let me move that there in case that's getting in the way. And South Australia is one of the states in Australia, and Australia is a commonwealth made up of states and territories. Each have their own laws and frameworks, their own parliaments, and then we have a federal Commonwealth Parliament that also has some overarching laws. And in Australia, when we speak, firstly, we acknowledge and pay our respects to the traditional owners of the land. And I saw from Christina that Indigenous issues are important to APRU, and I'm happy to see that. And this morning, I'd like to pay my respects to the Kaurna people, the traditional custodians whose ancestral lands I speak from, and acknowledge the deep feelings of attachment and relationship of the Kaurna people to country. And I respect and value their past, present, and ongoing connection to the lands and cultural beliefs. The Indigenous people in this in Australia have been around since the beginning, and they've sustainably managed the land. They will tell you, if you care for country, country will care for you. And I think that that's a great lesson to start with. The University of Adelaide this year turned 150 years old, and I'm very proud to be at one of the group of 8 universities in Australia, which is what our research-intensive universities. Lots of great universities in Australia. I think all of them are amazing in their own right. I am, of course, especially fond for my own university and the community I'm in. Like the other group of 8 universities, we're consistently ranked in the top 1% of the world's university. We're top 100 in many rankings, and in top 1% in the other rankings. And in the new sustainability rankings, we're in the top 100. Now, to me, I think we should all of our universities should try to be number 1. And I know that that's difficult, but in everything we do as a person, as a member of a community, as a member of an organization, we shouldn't think top 100's good enough when it comes to sustainability. We should strive to do our best. And if we learn from one another and collectively work to achieve that, I think we can. So I'd encourage all of us to get with our organizations and figure out how can we make a strategy to become more sustainable, not just for ourselves, but for our organizations, and how we project to our communities, our staff, our students, when wherever we're at, our employees, and work together to just say that what a great achievement it would be one day when all the universities have the same ranking, and that's number 1 because we're doing it as best as we can. So South Australia, global leader in renewable energy. And firstly, a little bit about me. You heard about me. I grew up in Arizona, and Arizona is a very dry place. And when I was growing up, a change happened that enabled us to do so many more things than the primary sectors that the state was so reliant on. And that was the state opened up a nuclear power plant. And this meant that with enough energy, then all of a sudden we could pump water from deep places or pump it around the state. We could use water. If with enough energy, we could convert waste from our trash and other waste. We could mine deeper. We could process more ore because that's very energy intensive. And so energy was very empowering when I was growing up in a state like Arizona. And I think anywhere in the world, energy is very empowering. And there's something I chat with my students about, and that is, many of you here, I assume, when I'm talking to this audience are interested in waste and waste management. And waste, in my mind, in very basic principles, is about managing mass. And if you are managing mass, then we know that mass is equivalent to energy. So there's a potential for energy. And if you have energy, you have the basis to do lots of good things. So collectively, again, I think that we can talk about how do we turn waste into an asset for human prosperity without compromising on the environment. And that's the real challenge. And we have some chats that we're having with colleagues because we've all heard about net zero energy and net zero water. And then when some colleagues talk about net zero waste, other colleagues will say, well, there's no such thing as net zero waste because waste is waste. So I think that that's actually a paradigm that we have to discuss and have to investigate together and find a way forward. From Denmark, I was very fortunate, from the Arizona, I was very fortunate to move to Denmark. And in Denmark, I worked for a consulting engineering company, and they allowed me the time to go become an environmental engineer because of the types of projects I was working on and needed to take responsibility for. So I want to put this in perspective about how new environmental engineering is. I think many people around the world would accept that Denmark is one of those countries that's forward-leaning when it comes to environment. I graduated in the first cohort of environmental engineers at the University of Southern Denmark in the year of 2000. That's not even 25 years ago. So all of you that are starting to study environmental engineering or environmental management, or you're still, in terms of a profession, at the tip of the pack. You're at the front of the pack, and you're moving and you're trying. And it means that when you do so, not everything will go right or perfectly the first time, but it means you're advancing. And when I was becoming an environmental engineer, we were taught that the solution to pollution is dilution. And what did we mean by that? There were laws saying we had to get under certain concentrations, for example, in water. And to do that, you would pump more fresh water into a system. You would measure again, and that water had diluted the concentrations under a certain level. You met your legal requirements, and that was an engineering solution. With waste, you would mix fresh dirt in, and then you could take samples again, and if you were under a certain concentration, you were okay, and you moved on. And with air, of course, you would pump in fresh air, and then at the top of the stack, you would measure again, and if you got your concentrations under a certain level, then you were okay, and you moved on. Back then, not even 25 years ago, the solution to pollution was dilution. And now modern engineers understand that that is not right. That's not the best for human prosperity. It's not the best for the environment. We understand that the solution to pollution is not to pollute. So we are working very closely with colleagues across many disciplines to ensure that in whatever we're doing, we're considering the environment first, and that we're trying to make a positive impact while enabling prosperity. And that is a huge challenge, and one that requires systems thinking and talent from all around the world. So I commend you all for the journey you're taking and for advancing the profession in such a short a time. So Denmark, for many years, with respect to renewable energy, was at the front of the pack, doing as much as it could. But even Denmark was and is still converting from fossil fuels. It was only yesterday that the coal-fired power plant on the island I lived in, Denmark, was closed. just yesterday. So Denmark's still undergoing a transition, but it's being driven by amazing knowledge and effort that those on this call are contributing to. South Australia, I think, is an amazing case, because from Denmark, I moved to South Australia about 6 years ago. And one thing I noticed right away was how much variable energy, renewable energy there was in the system. And it's an amazing story, and one I'd like to share with you. So about 15 years ago, the South Australian government made a decision that they won't have coal-fired power plant. That's simple. The government made a decision, and they moved instead to a large portion of gas, if you look up, and then probably just the same amount of wind that was being developed as the gas. So you had wind as a variable renewable energy, and you had a firming capability, as it's called, to ensure baseload power and adjusting for spikes in power demand from natural gas, which is very abundant in South Australia. It's one of the resources that this state has. And then you had this little amount of solar that was on a growth trajectory, but 15 years ago, it might not have been as reliable as today, or as accessible, or as cheap. And but it was going to grow in a situation where the government said, no more coal. And as you go from back then to now, you can see that the amount of gas is falling, not because wind has grown so much, but because solar is growing an enormous amount. And solar, this puts a new challenge for us on how we build, how we manage microgrids, how we deal with electrical systems that are meant to transmit in one direction to a market from production, rather than speak with one another, with houses like myself that I was lucky to purchase with enough solar panels on the roof and a battery pack to ensure that I could run many days at my home without using electricity from the grid. And the question is then, if I'm not buying electricity from the grid and many others aren't, what happens with that overage of electricity? And if we're not purchasing it from power suppliers, how does the state and the power supplier pay for upkeep and all the things that have to happen for us to actually have a grid? So it creates interesting sets of challenges that modern societies that are making this journey try to move towards. And now today, South Australia is that jurisdiction in the world with the highest amount of variable renewable energy. And a lot of the reason that we don't have 100% variable renewable energy, but we will, is because of the heavy industries we have in South Australia. And those industries include our steelmaking, for example, our cement, our minerals processing for our critical minerals, and our mining processing, because crushing rocks takes a lot of energy. And in this state, for example, one of our large mines can use, for example, around 30% of the annual energy use for the entire state. And that's because going from big mass, big rocks, to fine materials that can be processed for the minerals we need to electrify takes a lot amount of energy. So Australia's largest operational hydrogen electrolyzer was built in this state, in this city, and it's small. And it's small compared to so many other power sources, but it's there. And it's allowed us to gain confidence as a state, working together with the universities and academics to find new pathways to enable the state to make a commitment to build the world's largest electrolyzer. And that's what's on the horizon. So if you look at the renewable energy facilities in South Australia, We now have a good mix of wind, solar. We have large battery storage, Tesla battery parks. We have an interconnectivity that allows us to go from areas where there's lots of wind or lots of sun to areas where we're doing our heavy industry activities or manufacturing. And now in the future, we're also connecting that with the water needed, because water is also very often a limiting factor for many of these processes. So when you talk about energy and water, if you link that up, then you're able now to manufacture and produce. And if you do it in a way that minimizes impact on the environment, then not only are you generating green products, but you're also generating know-how that you can export to the world. And then the last bit I think that we all need to work on together is what to do with whatever waste products that are coming out. So I'm really honored and proud now to be in South Australia, and was just as honored to be in Denmark. It's amazing that when we choose academic careers or international consulting careers, or even working in government where you're able to travel around, you see that each one of us in our own jurisdiction has some things we do really well that could be done in other places, and some things we should learn how to do better. And that's okay. We should learn from one another. South Australia has unique energy resources, a lot of sun and a lot of wind. The question is, how do you export that then? And you do it through value adding it and other products and services. It really is a renewables pioneer. There's other places that are as well. South Australia is one of those few places I've personally seen where you'll have a combination of solar, wind, hydrogen as an energy system. The only type of energy we don't have in South Australia or in Australia is nuclear. That's federal policy. We do have a small nuclear reactor for medicine purposes outside of Sydney, but otherwise there's no nuclear in this country. And it's a very open for collaboration, this country. And I understand from Professor Oak that he's working with the Australian Embassy, and he comes very often to Australia. And I'm very proud to be in a country where universities, industry, society, we don't really see each other as competitors. We work together. And so it doesn't really matter what university you're at here. You find common ground and work together where it makes sense, because we're all interested in sustainability and trying to do better things for the world. If you look at, again, what exactly we have at this stage, we have 22 wind farms. And I'll get back to what that means, because there's a lot we have to think about there as environmental engineers. 3 solar farms. We have the world's highest uptake rooftop solar per capita, 4 grid scale batteries, and Australia's largest hydrogen electrolyzer already here, and we'll soon have the world's with a 250 MWE electrolyzer that's going to generate 200 megawatts of power generation and hydrogen storage right next to where we produce steel. So that opens all types of opportunities, and it's right down the logistic pathway from where we produce copper. It's a lot of renewable energy, and it's needed to be able to do not just power the city of Adelaide, which has about 1.2 million people, but the rest of the next million spread around the state, but especially meet the power demands of these heavy industries and mineral processing operations. Again, because you can't have solar power without the minerals. You can't have hydrogen without the minerals in the electrolyzers. And you can't have wind power and wind turbines without the steel in the towers and the cement and the foundation. And if you add hydro, you'd need the cement for the dams. So there are lots of pressures on getting to the green electricity to electrify society so we can move away from coal and other fossil fuels, that we have to balance these systems to ensure that ultimately we're getting to a true green output. And that's a challenge, and it's difficult anywhere you go in the world. So South Australia, as I mentioned, doesn't have nuclear. And if you don't have nuclear, in my opinion, you need to look at hydrogen. And hydrogen, I think, will secure South Australia's leadership in renewable energy for a number of reasons. It's going to enhance South Australia's grid security through dispatchable generation. It's going to provide green hydrogen production and generation technology at scale and prove that there's a market for it. Because we already know there's a market for hydrogen. It's just produced by different means, and it's not necessarily green hydrogen. So proving that it can be done with green hydrogen is actually not trivial. It's going to then unlock a pipeline of renewable energy development and associated manufacturing opportunities, because we are endowed with resources here and our friends are endowed with resources. And if we get back to the first point about providing security, in my opinion, there's two main pathways to provide security. One that I'm not such a big fan of, but we all have to do to some degree, is looking inward and using our energy and our resources to provide first and foremost for ourselves, a type of nationalistic approach to energy security. The other that I'm a fan of, and that I learned about actually in Romania, is this, well, from Romanians, not in Romania, but from Romanians, was the notion of being secure because you are trading energy all different places with friends. And in return, you're getting things you need from friends. Great friendships produce great trade, and together you stand stronger with respect to energy security and many other forms of security in the world. And I believe in that. In Australia, it's very difficult to trade sunshine directly or even hydrogen directly, because hydrogen, pumping it as a gas into some ship and trying to ship it is very expensive. So you have to think about what can you use with that hydrogen or energy and value add and trade that instead. Because chances are, amongst friends, you're probably already trading products and services that if there's a cause to produce them or manufacture them with goods that have been produced from green energy, there might be a premium, a price premium for those, and trading those, in principle, now you've found a way to export Australian sunshine or Australian hydrogen with something we all already know we already need and have the contracts for. And so this is another demonstration of how engineers can and should work together, not only with other engineers and technologists, but social scientists and business people to find the new business models of the future. And those, as engineers, if we're in the consulting world, will be our future clients as well. They'll need our assistance. So we talked about this export-focused project. It's about exporting your energy through value-added products and utilizing value chains you already have. And getting to a clean energy transition, we want to get to net zero in this state. Other states are committed to it. Companies are committed to it. And the question is, how do you do it? And companies have a difficult time doing it unless countries or jurisdictions such as South Australia underwrite the energy production with green energy. Lastly, because South Australia and Australia in general has been endowed with resources that they have mined and shipped away, it's not a very complex economy. By value adding with these resources, which I think makes sense when you've created the resource and can demonstrate they can be considered green resources or as green as possible, greener than the nearest competitor's resources, then you're able to create greater complexity in the economy, and that's a good thing too. And if you look at an index with how complex economies are, South Australia actually scores, or Australia in general would score very low. And there's no reason for that. And I think that the federal government has now launched a new national manufacturing initiative, which I think will add to making this country more complex. And just as you manage a portfolio of personal investments, the more complex you are and the more able you are to spread your opportunity over diverse types of risk, the better general outcome I think you'll get in the long run. And that requires complexity. I'm not an economist, but as an engineer, I think we see this as well, that we have simple solutions for simple things, and some complex systems require complex solutions, and we get that. And in general, when we learn about the complex solutions, we can dissect those and turn those into a number of simple solutions for simpler things. So there's this cycle of learning that I think we'll all contribute to, and as a society becomes more complex. South Australia has, with respect to copper reserves, the second largest copper reserve in the world. But it's only producing at about the 6th or 7th level on any given time. For the right reasons. We're protecting our labor force with how we our labor laws and how we deploy those. And we're protecting our environment, especially compared to other jurisdictions that might be more willing to compromise environment to mine and process minerals. Copper is absolutely needed to electrify the society. And you can see from the scenarios here that there's a gap between the supply and the demand. And this gap isn't just for copper when you're electrifying. You can look at the minerals required for solar batteries one day, or for batteries in cars, or for, solar cells, or for the electrolyzers, the platinum group metals used in those. You'll see these gaps because the demand for green energy is growing faster than the supply of minerals to get to them. With the case of copper, you can't electrify without it. You can use aluminum or aluminium, depending on your dialect, to replace some of it, but you have to have it to electrify. Double current global production is needed in the next 30 years to meet the projected demand. For people to meet their net zero targets to electrify, you have to double the current production. Exploration for copper is difficult. Global average says that it takes 16 years to go from finding copper to producing it in a mine, because there's a long process to get that done. So all these ways that we mitigate and create circular economies that we think about as engineers, for example, recycling or replacement, it's not going to help. The copper we have tied up for a windmill, for example, is going to be tied up for that 50 years or however long that windmill is. The same with the copper in our buildings. And let's get back to this windmill case and compare it with copper and the requirements. To replace one standard coal-fired power plant, which is producing about the same amount of electricity our new hydrogen plant is going to produce, you need about 17 windmill farms if you're replacing that energy with wind. Now, each windmill farm has about 100 windmills in it. And each windmill, and I'm using an Arizona term for wind turbine, excuse me, each wind turbine, to be more correct, the motors and the cabling, it's about 8 tons of copper in each one. So 8 tons of copper times 100 times 17 to replace one coal-fired power plant. Now let's ask ourselves how a mine where the copper enrichments are very good, like the mines we have in South Australia, how much rock, or miners call it ore because it contains copper, do you need to mine and process in general to get to that 8 tons of copper? It's 110 tons of ore. It's a lot of rock. And that requires a lot of energy and a lot of water. And that's just to get to the copper needed for one windmill. And now, as I mentioned, and we're using averages, the numbers and motors, of course, vary. Multiply that by 100 for one farm, and now you need 17 farms. Oh yes, and now you need the copper or the aluminium to connect all the farms and connect it to the grid. So it's a lot. So mining has got to be part of the solution. And people who are coming from countries where you mine, find out how to work with the miners to help them mine even more efficiently, to solve this paradox of how we're going to get to the minerals we need to be greener and to have green electricity without impacting our environment much more than we're doing. So again, the International Energy Agency, IEA, just a couple of years ago, shows a looming mismatch between the world's strengthened climate ambitions and the availability of critical minerals that are essential to realizing those ambitions. So for us as engineers, there's opportunity in there, and we figure out how to work together to help it meet this demand without compromising on the environment. This is about the existing supply and demand gap. Any way we look at it, the supply and the demand gap is growing. And you can see it in the prices for copper. When I was growing up in Arizona, which also is a copper producer, prices of copper fell to pennies per ton. And now it's up over, hovering between 12 and 14,000 US dollars per ton. And the question is, if somebody could make copper with green energy, and let's say call it green copper, what would that be worth? Green steel seems to be trading at a premium, sometimes as much as 25 times the price of non-green steel or non-decarbonized steel. But how do you prove it? And I asked some metal traders, and they kind of made light of it. And it takes us to another important point we have to realize about engineers and our role in society. And I said, well, how do you know you're trading something green? And they said, because the seller is telling us it's green and the buyer trusts it. And that's the basic market mechanism. And yes, one day scientists will figure out smart ways and using blockchain and other ways to trace green provenance. But right now we have trust. And all of us on the call are from countries and positions where we can trust one another and trust on the science and trust on the engineering. And that's very powerful, and it doesn't cost us anything. So keep working on trust. And as a civil engineer, which I started my bachelor degree on, we realized that building bridges is done by people and happens between people. So the more we can bridge people, the better. And we also realize that our foundation is critical for the height of our aspiration, how high we can build. So as you're getting your education, make sure to get your foundations right, because that will empower you for future growth as professionals. And I think, as you can see, there's no shortage of opportunity. This is just copper, and it's essential, but there are also other essential minerals. governments call them critical minerals, and they're different depending on what country you go to. It's a mineral that's important to the country, indeed critical to the country and its supply chains. Some governments, Australia including, call them strategic minerals. And there's strategic minerals that don't quite meet the criteria of critical because they're easily found in the environment. Something like copper is called a strategic mineral in Australia, but it's critical for other reasons, just not on a list. These titles, critical minerals, strategic minerals, even rare earth elements that aren't all that rare, are based on the availability and the supply. So if you look at this case, again, of just copper, the copper mining companies and many other mining companies say, we're part of society. Society, we're listening to society. They're asking us to get to net zero. The question is how? They need to use less energy, less water. They need to reduce waste, and a special type of mining waste is called the tailings. This is what's left over after they've mined or processed. And that requires a lot of environmental engineers. You can't just watch prices rise and take profit and not invest that into environmental social governments and solving and improving all these aspects anymore. Society demands it of universities, of companies, of ourselves to do better. And indeed, one of the Anglo-American CEOs said, the society will not tolerate the way we operated before. And getting back to how I was initially trained as an environmental engineer, the society will not tolerate engineers who just say the solution to pollution is dilution. They expect more of us, and rightfully so. We've advanced our knowledge, we need to deploy it. So why not just reduce demand for these materials by replacing them? As we know, as environmental engineers, you can replace things. With energy and storage, for example, from hydrogen, well, the paradox still applies. And even with fossil fuels, the paradox applies. So it's not a question of if we need to make the investment, it's how. And the people making the investments require all of our knowledge to do it in the most sustainable manner. Getting to a circular economy, you can't snap your fingers. It's a transition, and it needs to be thought about as a system-based solution. So again, paradox from heavy industry, and we've talked about that, you go from some energy to process something that requires a lot of energy. That's why it's a heavy industry. And then you get to products and byproducts. Some of them have utility, others are considered waste. And the challenge for all of us are to find utility in the waste. One person's trash, another person's gold. And so the less waste we generate, the better the outcome is for all of the environment. And the common challenges are not just technical, they extend into the market and policy content. So rounding out the talk, one of the ways I encourage my students to think is something I learned studying business, where in international business, you would do what's called a PESEL analysis of a country to decide if it's a good place for your company to get established. And I think it can be applied to how we think about environmental engineering systems. And in modern times, it's been unfortunate, but we, or at least I, have added in an S to PESEL, and the final S is for security. So you're looking at what is the political landscape, the economic conditions, the socio-cultural conditions, the technological possibilities, the legal environment, the environmental conditions, and security when you're assessing a new initiative. And if you look at this amazing hydrogen initiative that's happening in South Australia and other states in Australia that are moving to hydrogen because, again, the country needs some way to firm the energy and also to export its sunshine, so to speak. There's a political willpower. It's been demonstrated in South Australia time and time again. There's an economic impetus for it and a foundational drive to do it better. You can see that as the supply and demand curves diverge, for example, for copper, and they'll do that for many other critical minerals and strategic minerals. There's a socio-cultural demand. People expect us to become green, to electrify, to get to net zero, but to not do it compromising our environment or indigenous land rights or anything else that actually would hurt us more than advance us. The technological aspects. We have great understandings and we're advancing our profession as environmental engineers all the time, but there's much to do. And irrespective of the technologies we look at, we're asking ourselves, how do we really recycle batteries? How do we really recycle solar cells? How do we recycle wind turbine blades? There's lots to think about. The legal environment. In South Australia, they created a law for hydrogen. One of the first places in the world specifically on hydrogen. And that's to encourage that anybody here coming to work in the hydrogen value chain understands the legal framework and guardrails. And that's very powerful. And as engineers, we can work with the legal colleagues to ensure that the legal environment doesn't become a barrier for the technological solutions available, but indeed becomes an attractor for them. The environmental aspects, we understand there's this paradox, and we have colleagues studying environment, conservation, biodiversity, and this new concept that we can actually be nature positive, because it is a new concept relative to my lifetime at least. And how do we incorporate that into our engineering thought? I think that's there. And at the University of Adelaide, we're leading a coalition right now across Australia focused on nature positive to try to win a major grant together with industry called a Cooperative Research Center. And fingers crossed to that team for that very important effort. Lastly, security. And getting back to the lessons I learned from my Romanian friends, security can either look inward as a baseline or look to friends and networks and friendly networks. And there's probably a combination in there that's required for countries. But I encourage everybody, when they look at their technical solutions, to think about the security aspects involved, because we have to engineer to protect against them. And security doesn't have to mean a nefarious thing. Hydrogen can be dangerous if it's not engineered right. And to my knowledge, there's nobody engineering a specific hydrogen engineer yet. So you have to think about, how do you do this in a way that is going to drive societal confidence in this new technology, so that one accident doesn't lead to it being discarded. So security is important. And the same way when we evolve environmental solutions, if the solution you propose doesn't end up with the intended impacts and you have some sort of environmental management crisis, then society will lose confidence in us and our solutions. So we need to be sure that what we do is as best as possible and not just meeting legal briefs when we know we can do it better for very little extra cost. It's worth it in the long run. So with that, I'd like to just remind us all that copper and other materials are essential to getting to green energy. As environmental engineers, as sustainability people, when we're getting to materials, we're generating waste, we have to understand how to manage them. And there's colleagues like Professor Oak and many others on this call that have devoted their life to allowing us to understand how to do this better. And it's such an honor to get to be here today so that together we can all help meet this demand sustainably without compromising on our values. So Professor Oak, colleagues, audience, thank you for listening, and thank you for having me, and I'll look forward to the panel and any questions.
Thank you so much.
Thank you very much, Professor Goodsite, for your talk and interesting insights about renewable energy and especially about the potential of hydrogen. We have a polite request for our attendees now. We would like to capture a group photo with all of you at the end of the panel discussion. Since we are conducting the session in a Zoom webinar mode, it comes with its own set of advantages and disadvantages. To ensure that everyone's videos are visible, we will need to promote each attendee to the panelist role. Our co-host will assist in promoting you as a panelist towards the end of the session for the group photo, and we'll kindly ask for your cooperation and understanding for this. Thank you very much, everyone. Now let us move to the panel discussion. Allow me to introduce our esteemed panel members for today's session. We have Associate Professor Shumi Akhtar from the University of Sydney Business School. Professor Akhtar covers diverse research areas including governance, ESG, AI, machine learning, financial and cybercrime, corporate finance, among others. Her research publications have appeared in leading international and local journals. She was a recipient of the Australian Research Council's Discovery Early Career Researcher Award Fellowship. Several of her research papers received local and international prestigious awards. Next, we have Associate Professor Qingshang Ren from the Hong Kong Polytechnic University. He has been selected as the only winner of the 2022 Asia Pacific Economic Cooperation Science Prize for Innovation, Research and Education, the ASPIRE Prize, in recognition of his scientific contributions. His research focuses on process systems engineering for energy, environment, and sustainability. Now, we will get started with the panel discussion. The panel discussion will go for about 20 minutes. We'll also request our attendees to post their questions freely to the chat box or raise their hands using the raise hand function on Zoom to ask a question to the panel or discuss something with them. Professor Goodsite, over to you.
Thank you. So, panel, I'd encourage firstly to introduce yourselves and reflect a bit on how your own area has a corollary with the talk. And so if we can start with Professor Akhtar.
Thank you, Professor Goodsite. It was a fascinating talk you gave. I was just in awe that, oh, wow, so much happening in South Australia. And again, as you said, rightly so, we need to talk about this more and educate our future generation, because they're the one who will be leading any work we do or initiate today. They're the one who will be the bearer and take it forward. So thank you for this opportunity to serve in the panel. And obviously, just to give a little brief overview myself in terms of my research, I'm at the University of Sydney Business School in the finance discipline. And my research brings different disciplinary work together to be able to address more challenging questions. So of course, my home discipline still remains finance, but I try to do collaborative work with the law faculty or with computer engineers or even the scientists, just to understand the grand challenges. And as Professor Goodsite correctly mentioned, that these problems are not, no matter how expert you can become within your own discipline, the problems are multi-dimensional, and therefore you need multi-dimensional talents. And that means that our collaborative work with the different disciplinary expertise and experts would be the best way to move forward. So in terms of my research, I essentially look into more like in terms of the corporations, like large corporations, multinational corporations, and also the medium and small size businesses as well. But as you know, there is going to be, in Australia, from mid this year, there is going to be a reporting requirement by the federal government in terms of the ESG or climate compliance like as they do their operations and businesses, how compliant they are. And obviously that, that raised some controversial discussions because there is a discussion going on in terms of the greenwashing. It's just not a discussion. In fact, one of my paper actually looked into how does the ESG risk kind of spills over to other companies, especially if they're doing dodgy stuff. And one of the dodgy thing is the greenwashing. So many corporations in Australia, for example, about 57% of Australian companies have been identified as possible greenwashing. So they are going through a lot of court cases and so on and so forth by the Australian Security and Investment Council, the committee, because it beats the whole purpose of us to become sustainable or to become ESG compliance. Because as a business, of course, business will always prioritize their profit. But our great Nobel economist said it about half a century ago, that profit is yes, it is important, but it cannot be the ultimate goal for a company. They should be making profit given they are not causing any harms to anyone. So it goes without saying is that the research that we need in the ESG space or to become sustainable, Australia serves as a unique case because it's very resource-based country and very resource-rich country. And I'm so pleased that, we have got great scientist here, Professor Goodsite, and how he used this pestle, which I use every day. It's like the very first thing I will introduce to my classes, right? And I'm even more excited to see that how he brought the security part and the additional S to it. And I was thinking, perhaps we could probably think of adding another S if we need to, because it's the science part, which is not in that. And that's what I was actually workshopping with some of my postgraduate students and PhD students, especially when I give them some like the assignments or practical projects to work on. And obviously from finance perspective, it's all about cost and benefit I look into and the viability as well as the risk and return. So this return we are talking about from corporations perspective, they're always after making big money because that's their ultimate aim. But as you know, the society is no longer going to just tolerate companies making return at the cost of the society or the people that lives in the society. So it is coming to that to a point that we need to revise some of our outdated definition of return or the definition of risk, even from financial perspective. So we need to bring the science to it. And again, I'm so pleased that we are hosting this session where it is bringing together many different talents, and then hopefully it will get even better in future. So just to give you a brief overview of what I found with my students, the research project I work on, the greenwashing part. Greenwashing is prominent and it is happening is because there's no regulation, there's no mandate. So because it's a fancy word, as it seems like, people are, not people, but the corporations are taking unfair advantage of it. So they just think that, okay, well, if we want customers to buy more of our product, we should just say, declare in our website that we are sustainable, we are this and that. But this is just a talk. This is just an advertisement. They don't really do anything in action. And that's why they got caught, is that in your website, you are saying that your product is sustainable. Can you explain how is it sustainable? And it's like they drop from the sky because they don't have answer. It sounded good to write it on the website to be able to attract the customers, right? So this kind of behavior really beats the whole purpose of us to achieve what we want to achieve, and definitely goes against the UN SDGs, those 17 sustainable goals. So my research falls in the intersection of those UN SDG 17 sustainable goals with bringing different disciplinary expertise and also comply with the ESG. So hopefully, I was very much of an advocate actually to this new regulations that's coming in place. And funny enough, I was invited to serve as a panelist last week. And in that panel, there were a lot of corporate CEOs and CFOs and all those. I was the only academic there. And as it happens that they're very much reluctant to comply with these new reporting requirements. And my question was, what exactly is the problem here? That if you are doing the things right, and all you have to do is just report that this is what we have done in terms of action plans and activities wise, that embeds within our operation, and that goes to show that we are, doing the best we can for the society, for the environment. Where exactly is the problem? And none of them could answer my very simple question. And their argument was, oh, it is costly, it's going to be time consuming. I said, you can't possibly tell me when you have got billions of dollars of profit, and here you will give this task to your accountant who will be doing basically this report, and you will be providing the information to spend a day or two. If this report is not jagomas, it's a very simplistic report. And for that, the way you were saying that it is costly, as if like it's going to cost you $1 million. It's not going to cost you even a couple of $1,000. Couple of $1,000 is nothing, especially when you are earning $1 billion. And that just quietened them. So, someone needs to voice the concerns. And then obviously this in the society, you will have this 1/3 of the agents will be advocating to become sustainable. 1/3 of the agents just don't care which way direction it goes. And the other 1/3 will be always going against what we want to achieve. So us who are really conscious about and want to do the right thing and educate the future generation to do the right thing, it is a challenge, but we should not be, deterred by this challenge. To me, challenges are the opportunities, actually. Prove them wrong. That, it takes more resources to actually go against it than otherwise. That's in my view, really. So with that, obviously I don't want to dominate this whole discussion, but all I want to say is I was so impressed with Professor Goodsite's insight and some of the research he's working on. It is very relevant, very practical, high impactful, absolutely needed for Australia, if it is not already, well overdue. So with that, I just pass on to the other panel members, and then let's discuss some of the questions that we want to address here, which is already in the chat.
Well, thanks very much. I would love to get together and write a short editorial with yourself and anybody else on updating PESTLs. We were having a discussion the other day that there should be another L, because one of my students said there should be another L. It should be leadership, because leadership's different than governance. And
True.
Well, I'm glad you, because as an engineer, that sounded right, but it's good to hear it's right. But it seems, I love that idea of bringing in science and using it as a new way that engineers and scientists that are working with social and societal issues like yourself can bridge speaking together and creating impact. I'll now move to Professor Ren, who I've had the honor and pleasure of knowing over a decade, actually, and I'm so proud of his accomplishments and inspired by his efforts every day. Professor Ren, how's your research and what can you tell the group today? And you've studied industrial prioritization of hydrogen. Is this just a topic of the day, or is this something that's really needed? Does heavy industry have to use hydrogen?
Okay, thank you, Michael. First I would like to say congratulations. Okay, it is really a fantastic talk. Okay, I have attended the talk of Michael for at least 5 times. I think this one is the best. Okay, because this one, in my mind, it has both the academic value and also practical value. Okay, This is Jing Zheng from the Hong Kong Polytechnic University. My research mainly focuses on system engineering for energy, environment, and sustainability. Okay, we would like to recognize all the elements as a whole to promote, to solve the problem existing in energy, environment, and sustainability. Okay, especially about how we have developed the various tools for sustainability-oriented analysis, assessment, and decision making, and also sustainability-oriented design and optimization for all the processes, of course, including the hydrogen pathway. Especially, we have developed different innovative pathways for converting the waste into hydrogen and into some other valuable product. I would like to summarize what I have learned from this talk in 3 aspects. I would like to summarize in 3 P. The first P is process. Michael actually had already asked all of us a question. We have different processes for hydrogen production. For example, coal gasification, biomass gasification, and also water electrolysis based on electricity, based on the wind power, solar power, all different pathways. Okay, we have different pieces. When we read the paper or read the report, we will find, wow, there are so many processes for hydrogen production. Okay, we have different processes. So now there's a question. Do we have the priority order for all these processes? So how about Australia? How about Hong Kong? How about mainland China? How about Denmark and some other countries? Okay, for now in Denmark, they have enough wind resource. Okay, maybe they will focus on about power to X, including power to hydrogen. Okay, maybe in Australia, okay, another case. And also in Hong Kong, we do not have we do not have any resource about wind or power. So what should we go? So this is the first question we need to answer. How about the processes? Okay, we have different roads to go. So what are the right direction? This is the first P. Then the second P is policy. For different countries, okay, should we have different policy? How about the subsidy? How about the incentives? Okay, that can be used to promote the demand of sustainable hydrogen. Okay, here is another question. Is hydrogen really sustainable? Yes, we know when we use hydrogen, okay, the product will be water. It seems that it is 100% environmental sustainable. But there's a question we would like to ask, where does hydrogen come from? If it comes from coal, okay, from coal mining, transportation, pretreatment, and all the process until the last step for hydrogen utilization. Okay, so there's a question. We really don't know how about its environmental sustainability, and also whether it is cost effective or not. Then the third P I have learned from Michael is about planning. Okay, in the production or in the utilization of hydrogen, it may cause some other problem. We have mentioned, okay, Michael have also mentioned, okay, it can be produced from different sources, different pathways. It will lead into different capital costs, operating costs, and some safety problem. How about its social acceptability? So we need to consider how we can planning hydrogen from a holistic perspective, namely from the bird's eye perspective, to ensure that it is really useful. It can really help to solve the current problem about any security or any poverty. Okay, so I would like to, maybe we should consider multiple aspects, multi-X, namely about multi-stakeholder. Actually, the production of hydrogen and also utilization of hydrogen, it involves multiple stakeholders, not only government, investor, factory, companies, and also user residents. So we need to consider different stakeholders usually have different preference. So how we can incorporate all this in the planning and in our future development of hydrogen energy. Then second about how we should consider how we can incorporate multiple sectors. Hydrogen can be used in transportation, in building, in industry, just like Michael had mentioned, okay? So how can we distribute hydrogen for different sectors? And we also need to consider multiple innovation, okay? Hydrogen, okay, can be produced from different ways. It can also maybe incorporate with some other innovation, for instance, CCUS, because in the process for the production of hydrogen, it also leading to some other environmental problem. For instance, hydrogen, for instance, carbon dioxide emission, okay? Whether we can incorporate, for instance, the waste to energy process, and also the CCUS process, and about distributed energy system, as well as some other innovation in energy or environment to ensure that hydrogen is really suitable and safe in future. So my last question is that how can we make hydrogen really environmental friendly, cost effective, and have high social acceptability? Yes, so we may consider to discuss this. Thank you.
Thank you, Professor Ren. Look, that question you have, I think, would be a great topic of a paper to work on collectively, because I think if we had the answers, people would just be ready to deploy them. Thank you, panelists, for your time. Organizers, I suggest we move to question and answers, as I see we're rounding out our time, and I know you want to get a photo as well. But what an exciting, I'll look forward to working with Professor Oak and whoever else would like to work on a type of critical review. And it'll be fun, excited, needed, and we'll learn a lot from it. So over to questions.
Attendees, you can start posting your questions, or you can raise your hand so that we can unmute you to ask your questions directly to the speaker and the panelists.
Yeah, in the meantime, we've been collecting quite a number of questions from our university students and the audience. So I may ask just 2 to 3 questions to you, and you may select just 1 or 2. The first question is, does hydrogen power play a role in countries that have nuclear power? And then second is, will Australia have nuclear power? And the third, globally, what other countries have a plan for clean hydrogen? If you have any perspective, if you can share it with us, that would be great. Thank you so much.
So perhaps I can take the first question. Yes, absolutely. Hydrogen power can play a role in countries that have nuclear power. Nuclear power plants produce or can produce electricity without greenhouse gas emissions, making them a clean energy source as opposed to the term green energy source. However, they don't directly produce hydrogen. You have the electricity, and integration of hydrogen production with nuclear power can help optimize energy systems, balance grid demand, and support the transition to a low carbon economy. And will Australia have nuclear power? I can answer that, or perhaps my colleague, Professor Akhtar, would you like to answer that?
Yeah, sure. Sorry, if you just revise the question again, what was the exact question?
Will Australia one day have nuclear power?
I think it is more probable than not. Because again, nuclear power happens to be, it is costly at the beginning, but in the long term, it will pay off its benefit. And I mean, nuclear power is, you know, the word nuclear, it has got a negative connotation to it, as if like you are going to go in a war or something. No, it's not. The nuclear, it can be an excellent source of energy, and we should be using, I mean, you know, in the past 50 years ago or so, people use nuclear for different purposes, especially in the war zone and so on and so forth. We are now diverting that in making it a better use to have better energy, and which is going to be less polluting our environment. So my prediction is it is highly probable than not.
Thank you. Professor Ren, the question was globally, what other countries have plans for clean hydrogen? And you were talking, we know countries like Germany, Japan, South Korea, China, United States, European Union, all these jurisdictions, countries have plans. How about Hong Kong? Do you have plans for green hydrogen?
Yes, yes, I
Oh,
know
clean
that.
hydrogen.
There's a new plan launched by the Hong Kong government. Okay, they would like to launch the 100% okay, hydrogen vertical. Currently it is at the initial stage. Besides Hong Kong, I know also another country, Japan. They also have similar plan. How about to promote the demand of hydrogen? Yeah. To the best of my knowledge, because I working on about the technical aspect of chemical engineering, especially about waste to hydrogen. Okay, I do not do so much research about policy aspect about how many countries about it. Too, when I do some literature review, I found that even in some developing places or countries, they also have such plan. But the country, the most important barrier is about the cost that leading to the demand of hydrogen at the developing area. So I know for instance in the Asian countries, okay, for that in or some region, for the Hong Kong or Japan, they have some plan about to promote in large scale. Yeah. Sorry, Michael, you may mute yourself.
Thank you. Thank you, Professor Ren. There's one question about dark energy. Great question. I don't know. I don't know enough about dark energy to answer it. So we'll have to take that question on notice. Colleagues, we're getting to the end of our time, and I want to make sure there's time for a picture. So what I suggest is any questions we haven't addressed, please feel free to send them to me. I'll do my best to put a few words on them, and I'll get back to you with how I can answer. I do see, let's have one last question from, it looks like Dr. Arlegui or Miss Chiara Aleli Arlegui. You have your hand raised, and then we'll round out with a question. And with apologies, but I do need to round out as I have to chair a meeting at the university here. Ms. Chiara, can you unmute yourself and ask your question? I don't think we're getting that done. Professor Oak, can I suggest that we round out and take the photo now?
Yes,
Yes,
sure.
Samantha.
So we will collect any additional question. After that, we will try to follow up what we discussed and then share the material with the participant. So we will move to the next step.
Our colleagues are promoting everybody as panelists now so that we can see their videos.
Sure, sure.
Us a few seconds.
Okay, so Samita, you can give guideline continuously so that we can quickly be prepared.
Uh, 30 seconds more.
Yeah, people are coming in. Maybe you can explain one more time, Samita and Sachini.
So attendees, we are promoting everybody as panelists here so that we can see your videos. We want to take a group photo with everybody here.
Yeah,
Thank
so
you
if
for
all of you can
participating.
turn on the camera, that we can take a group photo together.
Yes.
Yeah,
Please
yeah.
turn on your
It's
cameras, everybody.
Okay. So let's take a photo maybe just for 20 seconds later.
Yeah.
Then Samita, you can count. Okay, Samita, we can take a photo now, so you can count it. Okay.
Smile, everybody. One more time. Smile.
Okay.
Yes. Okay. We are done. Thank you, everyone. We have now reached the end of the first session. And before concluding the webinar, I thank Professor Goodsite, our speaker for today's session, and our panelists, Professor Akhtar and Professor Ren, for their valuable insights and for engaging the audience to an enlightening discussion. I thank all our attendees for their participation. We extend our special thanks to the APRU and the APRU SWM program led by Professor Young-Sik Ok of Korea University for organizing these events and creating a learning and networking platform for students, researchers, and everybody. We request you to look forward to our upcoming sessions too. The next session is on May 21st by Professor Melissa Withers of the University of South California, who is also the program director of the APRU Global Health. Thank you once again, everyone. We hope you all have a great day ahead. Thank you very much.
Thank you so much.
Thank you very much.
You have a great day.
Bye-bye.
Thank you.
Bye.
Bye-bye. Thank you so
Bye-bye.
much.
Bye-bye.
Bye.